Welcome everyone. Let's talk about the 5 handouts that you picked up on the way in today. So you picked up 5 handouts. 2 of them are for today. The one called Building a Cell to Demonstrate Selective Permeable Membranes is today, and Section 3 vocab list. Those are both assignments that are linked under today's module that will get turned in electronically. They are due for you guys tomorrow. Okay, they are due tomorrow. Most people are getting most of these done before they leave here today though. But anything that doesn't get finished is homework for tomorrow. The last 2 assignments, or last 2 things, hang on. Those 2 are today. The guided notes, Section 3 boundaries. In the guided notes, there's 2 different ways you can do them. Do what's best for your learning. There is the video recording.
Welcome, biology student.
I would encourage you, if nothing else, to watch from about 8 minutes on, because that's when they start talking about hypertonic,
water and sugar are the same.
Hypertonic, hypotonic, isotonic, and I do use some kind of common language to kind of help you hopefully remember those things. But here is just the slides presentation that you can go through. Remember, do what's best for your learning of this material. I know some of you are probably heartbroken to realize that, hey, you aren't taking a quiz right now. Yeah, I know. I promised you a quiz. It has been postponed to Thursday or Friday on cell theory and cell organelles, similar to the one that we took last week, Monday. Okay, so that's been postponed for Wednesday or Thursday. Okay, the last 2 things, the last 2 packets you picked up are for Thursday, Friday, or Friday, Monday virtual days. So if you want to get a head start on those virtual day assignments, that's why they're there, so you can have them now. Okay, so of those 5 things, 2 are for today, 1's for tomorrow, 2's for Friday, Monday, or Thursday, Friday. So let me kind of talk about today's activity. I'm going to walk you through in just a moment on how to do the lab. During the lab, there is some time that you're going to let your cells soak. We're going to make cells. I put cells in quotations and mark because we're going to use something called dialysis tubing that has tiny little holes. Okay, so while those are soaking, there's a lot of vocab, and that's why we gave you the Section 3 vocab list. So you can get to it either from in-person agenda vocab list, or you could get to it from modules. But then there's a Quizlet, and this Quizlet matches all of your terms on that Section 3 vocab. So that's how we have intended for you to define, like, diffusion. What is diffusion? Diffusion is the movement of molecules from an area of higher concentration to an area of lower concentration. And you can write that down. You can be like, well, what's osmosis? Osmosis is the diffusion of water. So that's how we're going to ask you to get those definitions. We're trying to give you some kind of basic understanding of these terms, because there's a lot. I'm sure you guys are all aware of this, but this Learn feature right here in Quizlet is kind of a nice one. When you click on it, it will kind of, after you go through it, it's a nice way to kind of quiz yourself. Sometimes they ask you to type in like the word, which is a little tricky because spelling counts. I put like semi-permeable and I didn't put a hyphen in. It's like, did you really mean this? And be like, yeah, I was right. And so it's kind of like that. But it's a nice way to kind of quiz. So a measurement of how much solute exists within a certain volume. That's going to be concentration. Yeah, I got that one right. Okay. So it's a nice kind of way that you can quiz yourself when you're going through to see if you really understand these terms. Okay. So that's what I'm going to have you do while you're working on the lab. So let's take a look at what this lab is. So you're going to look at this sheet right here. All right. So in today's lab, we have some cups, and there's a cup here and a cup here. We're kitty corner on purpose. So where the cup is where you should go. There is one cup filled with liquid. The liquid has water, cornstarch, and salt. And what we're going to do is we're going to build what we put like quotes around an awful lot of times. And we're going to build an artificial cell. You gotta have those soaking. Okay, so you're gonna build these artificial cells. So in that bowl, there is some It's called dialysis tubing that is soaking so it's flexible and pliable. What you need to do is we're gonna make a cell, but it's like they're stuck together. So you just take your fingers and you rub it between your two fingers and it opens up. And then you just kind of keep rubbing it between your fingers. And now we have a tube. We have like a hose. It's just not a very good hose. And what we want to do is we want to make it so it doesn't leak. So we're going to take our cell and we're going to twist the end. And the directions talk about twist it like a Tootsie Roll, one end of a Tootsie Roll wrapper. So it's twisted. And then taking a piece of string, I always like to do an extra wrap on it. So go around and then go around again. Then we're going to tie a knot. If you question your knot tying ability, let us know. We can make sure it doesn't leak, okay? So that first thing that you use when you tie your shoes, your shoelaces, that first like over under pull before you do the loops, that's called a half hitch. Do 2 of those and then you'll be good. Okay, so you're gonna go through, you're gonna tie, or a square knot, if you know your knots, square knot would be great. So now I have my tube that should be secure and not leaking. You don't want this thing to leak. Then what you're going to do, and these start to dry out, so a little water on them kind of helps. When you rub it between your fingers, if it gets too dried out, it's not going to want to work anyways. So a little bit of water. The water is running in that sink on purpose just to kind of flush the lines because we're going to dump some like liquids down it, but also so you can get it wet. You have a pipette in your cup. There's a pipette that's yours that will get thrown away, recycled. When you're done, there's 2 pieces of string and then that's your cup. It's been used before, there's names on it, who cares? If there's a color, we're gonna recycle when we're done. So there is this cup and it has cornstarch, salt, and water. Do not throw this cup away. Do not dump this cup down the drain. Someone from my last class did, and I'm a little worried about running out of solution. I think I'll be okay. Okay, so this is your pipette. You're gonna use this as a stir, and you're gonna take your pipette and you're gonna fill your cell with liquid. And you wanna get it about half full. Some of this dialysis tubing is bigger than others, and you don't want it to look like a Tootsie Roll when you're done. Okay, so you know, like a Tootsie Roll wrapper is kind of like that, or double bubble, right? Gum is really wrapped tight. You don't want that. You want to leave some empty space without air. So it's going to look kind of something like that. Again, twist the end like a Tootsie Roll. Wrap it around twice. 2 half hitches or a square knot. Some of you I know aren't as good with knots as others. So if you need a hand, let me know. Mr. DeBoer knows his fishing knots. I know some other knots. 2 overhand knots. Okay, and there's myself. Okay, so then what you want to do is you want to come over to the sink, and we just put starch and salt water through here. So these are officially called the tufts. You want to kind of rinse your tufts. Okay, so you want to rinse any starch and salt, and then what you're going to do is you're going to take a bit of paper towel, gently dry that off, because on the back of that lab sheet there is a data table. And one of the things it asks you to do is find the mass of that before you soak it. So you're going to take this, notice how this is not a full Tootsie Roll wrapper, and you're going to put it on the balance, make sure it's been 0 before you, and we would go through and we would record the mass. Okay, so for example, my mass is 4.84 grams. Okay, 4.84 grams, Mr. DeBoer. Could you write that on the board for me, please?
Yep.
4.86, 4.84. 4. Okay? So then what we have is we have this bag. We now know the mass. Now what we're going to do is we're going to soak it. So you have a cup, and what your cup is going to have in it is nothing. Okay, your strings are in there. Make sure you pull those out, and you're going to put it in there, and then you're going to put some water in it. Now the water you're going to put in, it says warm. We're just going to use some distilled water, about a knuckle. Okay, because a knuckle is about how long? About an inch, right? So we want about an inch. Okay, and we're going with the knuckle measurement because yesterday we said about an inch, inch and a half, and people were filling their cups to this. This is not an inch or an inch and a half. 1 knuckle, give or take. Okay, a little bit higher, a little bit lower. The key is your cell submersed in the water? Mine is yellow because we're going to squirt some iodine in there, and we'll talk about why we're going to put some iodine in there later. Then you let it soak. Make a note of your time. Start your stopwatch. I don't care. Got to let it soak for 20 minutes. While those are soaking, you can go through and you can be working on your Section 3 vocab terms using the Quizlet, and you're kind of doing that as it's soaking. If you need some help during this, let me know. There are a few things you're going to be touching. You're going to be touching the 0 button on the balance. You're going to be touching the valve on the distilled water. There's hand sanitizer here. There's hand sanitizer over there next to the Kleenex box, and there's hand sanitizer up in the front. I'm going to say brown paper towel is not recyclable. Your pipettes are recyclable. Your cups are recyclable, but don't discard your cups yet.
I'd say the two biggest, and they haven't been really issues, but the two biggest issues, if you will, that we've had so far are forgetting to weigh. And again, both times before you weigh, dry off. And then second, in conjunction with weighing, rinse.
All right, so what you have is you have something called dialysis tubing. There's tiny little holes. So let's just pretend that this is your dialysis tubing that looks more like a Tootsie Roll than a square box. But pretend like this is, and this blue outline is the beaker. What we have is there's tiny little holes in this dialysis tubing. And in this, there is some small molecules, there's some bigger molecules, and then there's some water molecules. And then we surrounded this in water. So we're letting it soak, and what's happening is diffusion. Diffusion is concentration, moving the molecules from area of high concentration to low. So if I go up here with air freshener, I forgot to do this in a second. If I spray a lot of air freshener right here, and I'd be like, whoa, this is really strong. It smells like a pine forest I'm in, and you'd be like, I don't smell anything. But then what's going to happen is with time, if we were to say, hey, raise your hand when you smell it, what's going to happen is it's going to be, I smell it, I smell it, I smell it, and we're going to get further away, right? It's going to diffuse high to low concentration. And that's exactly what's going on here. But what happens is some of these molecules, like these blue ones, might fit through, but these green ones are physically too big to fit through the holes. So what we're trying to figure out is what molecules can move and can't move through this dialysis screen. So there's some terms that you define called like semi-permeable membrane or selectively permeable membrane. And the term permeable means like able to go through. Okay, so if I open up a window that has no screen, what can go through that window? Maybe us, right? Depends how big the window is. Okay, what else can go through that window? Bugs, air, water, lots of things, right? We would say it's permeable to just about everything. Now, if it's a window that is this big, now it's impermeable to me though, because I can't fit through there, right? But it's permeable to some things. So if everything goes through, we can say it's permeable. What if I close the glass? Then what can go through that? Like that window right there, what can go through that window right there?
A lot.
Light,
With the glass on.
okay? But besides light, really nothing, right? Hopefully air is not going through our windows. We have bad seals if that's the case. The rain should stay out, bugs should stay out, birds should stay out, I should be able to stay out. So we would say that besides light, that window we could say is impermeable. It doesn't let anything through except for light. But let's just pretend, okay, so it's impermeable to everything else. But what happens if I open up a window that has a screen on it? Now what can go through and what can't go through?
I mean, technically you still can, you just break out the screen.
Without breaking the screen. What can go through?
Bugs.
Bugs cannot go through.
Air.
Can go through.
Small enough. maybe.
Small enough bugs,
Yeah.
right? So like gnats maybe, right?
Rain.
Water could go through, rain could go through, air could go through. Hopefully not bugs, that's often why we have screens. Birds hopefully can't. We shouldn't be climbing through window screens. Okay, so we would say they're impermeable to some things, but permeable to others. So that's the term semi-permeable or selectively permeable. And that's what we're trying to figure out is what can and cannot go through these. So what we have is so we put iodine in your beaker, your cup. And what your beaker or your cup is going to look like, why don't you do both, Mr. DeBoer? I think that maybe is going to be a little bit better.
Yep.
Is your cup will probably look like this, kind of yellow in color. Okay, and that's just because it's iodine. Iodine's yellow. Okay, but what happens is we're testing for something called starch. And when starch and iodine come in contact with each other, we get this purplish, blackish color. Okay, so this is what it physically looks like, but in terms of word description, that's what it is. Okay, what that means is that those two things came together, and we can say that's a positive test for starch, which means it's present.
Present.
Starch is present. So we put iodine outside your cup. So if it's purple, black colored, that means that the starch came out of your cell and it came in contact with the iodine. That's what we're testing for. And that's what your data table, there's some question color observations, and that's the reason for it. Okay? We are asking what is the color of your cell, because if the inside of your cell is kind of like that white milk, kind of looks like thin milk, if that is still white and milky, then that means the iodine did not come in contact with that starch. However, if it's a positive test inside your cell, what that means is the iodine was able to fit through those holes and go into it. So if it's a positive test, that means they came in contact with one another. If it's a negative test, they didn't come in contact with one another. Okay, so it talks about whether it's present or absent. The other thing we're going to test for is something called silver nitrate, or we're going to test for salt using something called silver nitrate, AgNO3, silver, AgNO3 nitrate. So it's kind of hard to see this one, so maybe you can get the lights for me again. So this is what a negative test of silver nitrate looks like. It looks clear. Okay, now yours is you're going to be testing your iodine, your water that's already yellowed. But clear doesn't mean colorless, just for the record. So something can have like a yellow color but still be clear. So if it stays clear, there's no salt present. If we do have salt present, this is what a positive test looks like. So it's kind of white. It looks like white streaks of clouds in the sky. Or we talked about like...
Put coffee creamer, like if you ever put coffee creamer into black coffee, you kind of get those swirls, and that's what it'll look like. So when we first add that, I encourage you to be right there, be looking, because you'll see that firsthand if it's a positive.
And those colors, those observations are being made here. Okay, they're being made here, here, and here. Okay, the other thing you have to fill out is you need to find the mass after. So you recorded the mass of your cell beforehand, and then what we are going to do is you're going to take the cup, your cell out of your cup after 20 minutes. We're getting close to everyone needing to do it at this point, though. You're going to take that cell out of there. You're going to gently dry it off again, because we want the mass of just the cell, and find the mass. If it gained mass, we're going to say, hey, that mass must have come from water flowing in. If it lost mass, we're going to say, hey, water must have flowed out. Okay, then there's a couple questions that are asking you that are kind of like conclusion questions based upon your data. And then there's kind of a summary table on the bottom of it. Okay, so we're kind of at that point, whether you're at 20 minutes or not 20 minutes, you should probably be pulling these out of your solutions, making some color observations, finding the mass. Again, we don't have to rinse the cell, but we do need to dry the cell. You did put iodine in your cup, so if you're sensitive to iodine, someone in one of Mr. DeGrand's classes said that they were, let us know. We don't want you to have any reactivity to iodine, so let us know. All right, so it has been 20 minutes, and we're going to go through, and we're going to use our mass. So our starting mass was at 4.84 grams, and when we take this out, we should be able to make some observations about color. Okay, so this is what our cell looks like after it's been soaked. So notice how it's kind of purplish blackish. That should get filled in on your data table. Okay, we're going to gently dry this off. Okay, we're going to gently dry this off. We are going to find the mass. Our mass is now 6.08, so it went from 4.84 as our starting mass to a final mass of 6.08. If we make some observations about the color of our cup, where's my camera? It's still kind of a yellowish color in our beaker. Okay, so that when we talk about positive versus negative test, when we go through, we're going to add silver nitrate. Silver nitrate is going to be our test for salt. We are going to go through, where again is my camera. Okay, and when we add a couple of drops into there, hopefully you're seeing kind of that coffee creamer effect. So we should be able to say, hey, that's a positive test for salt. So there's salt in this cup. However, it was a negative test for starch, so therefore there is not any starch in there. So if you aren't with us today, you should be able to use that as your results and be able to answer all the questions and the summary questions at the bottom.